All right, here in this lesson 8.3, we're going to look at exponential functions. You'll notice here right away it says a function of the form y equals b to the x, where b is greater than 0, but b does not equal 1. So there are those couple of stipulations on there. You want b to be positive, and that doesn't mean you can't have a negative out in front of b, like a negative 3. It's just that the value of b has to be positive. We don't want to be a negative 2 to the x power. The reason we don't is because we would end up having imaginary numbers inside some situations. And the reason we don't want b to equal 1, because if you have 1 to a power, then it's always 1. So it's not actually exponential. It would just be a line. So we're going to look at the graphs of exponential functions. And we're going to start off, this is the first time we're looking at this. So I've always mentioned when you graph a new function, it helps to plug in numbers and to see what you get. And then you can oftentimes follow a pattern and recognize why that pattern is true. So we're going to start off, we'll make a table here. And we'll start off with, I'm actually going to do a kind of opposite today. 3, 2, 1, 0, negative 1, negative 2, and negative 3. So if we have 2 to the x, if we plug in x, we would have 2 cubed, which is 8. So we would have the point 3, 8. Put in 2, that would give us 2 squared, which is 4. So we have the point 2, 4. Put in 1, 2 to the first is 2, so we have the point 1, 2. Put in 0. Anything to the 0 power is 1, so when you get in 0, is 1. Negatives. We discussed earlier that a negative, and we're going to write this out here, running a little bit out of room, but if we had 2 to the negative 1, a negative exponent means you do 1 over, it means reciprocal, so 2 over 1 to the positive 1, 2 to the positive 1 is 1/2. So this is 1/2, which means we have the point negative 1, 1/2. Let's make this a little larger. Putting in negative 2, 2 to the negative 2 means we have 1 over 2 squared, which is 1/4. So negative 1, 1/4, and you might figure it out by now, 2 to the negative 3 is 1 over 2 cubed, which is 1/8. So 1/8, which is negative 2, negative 3. This was negative 2, negative 3, 1/8. Sorry about that. So let's go ahead and graph these points. So we have the point 3, 8. We have the point 2, 4. 1, 2, 0, 1. These are going to be a little bit harder. We have negative 1, 1/2. I don't know how big we can get here. 1/4, 1/8. So there's the points that we were looking at. Now, if we think about this pattern, if we were to put larger numbers in, if we put 2 to the 4th in, we get 16, and they really keep increasing quickly. Down here, these keep getting smaller and smaller, but notice no matter what I do, even if I put 10 to the negative 20th here, it would be 1 over 2 to the 20th, which is still a really small number, but it never gets to 0. So over on the left side, this graph gets closer and closer to the x-axis, but does not hit the x-axis. So there's the shape. That's y equals 2 to the x. Let's come over here and graph y equals 3 to the x. So we'll have x and y, which y is 3 to the x. We'll do the same thing, 3, 2, 1, 0. So we have 3 cubed, which is 27. So we have the point 327, which will not be on our graph, because our graph won't fit that, but it's still part of the function. Put in 2, 3 squared is 9. So we have 2, 9. Put in 1, 3 to the first is 3. 3 to the 0 is just 1. So So the point 0, 1. So as we noticed before here with our negative exponents, it's going to be 1 over that thing. So 3 to the negative 1 is going to be 1/3. Again, let's look at that. 3 to the negative 1 means 1 over 3, and we want the positive of that. So 1 over 3 to the first, 3 to the negative 2 is going to be 1 over 3 positive 2, which is 1/9. So we have 3 to the negative 2 is 1/9. And this will be 1/27. So this gives us a few more points, negative 1, 1/3, negative 2, 1/9, and negative 3, 1/27. So we'll graph those. We have 327, which is way off our graph. 2, 9, 1, 3, 0, 1. And it looks like the same thing happens, except that to the right of the y-axis, it's even steeper. To the left of the y-axis, it gets closer to that x-axis quicker. So this would keep getting closer and closer to the x-axis. It's hard to draw that in there with the thickness of this, but there's the graph of that one. They look very similar, except again, it's steeper over here compared to the x, and that's because we were using a larger number. These two graphs are called exponential growth. Exponential growth. They are getting larger from looking left to right. They're going up left to right. So let's take a look at these next ones. So same idea. We'll put in 3, 2, 1, 0, negative 1, negative 2, negative 3. You're going to notice something here as we go through this. So this is 1/2 cubed, which is 1/8. I'm not going to write the points. It's just 3 and 1/8. 1/2 squared is 1/4. So we have the 2 1/4. 1/2 to the first is just 1/2. 0. So 1/2 to the 0 is 1. Now 1/2 to the negative 1. I'm going to write that up here so we can see it. This negative 1 means 1 over 1/2 to the first. Well, this is 1 divided by 1/2. Dividing is the same as multiplying by the reciprocal. So the reciprocal of 1/2 is 2 over 1. 1 times 2 over 1 is just 2. So we got 2 here. I'm sorry, wrong one. We have 2 here. 1/2 to the negative 2 is 1 over 1/2 squared, which is 1 over 1/4, but dividing is the same as multiplying by the reciprocal, so we have 1 times the reciprocal of 1/4, which is 4 over 1, which is 4. And then this one will be 8, because we'll have 1/2 to the negative 3, which is 1 over 1/2 cubed, which is 1 over 1/8. And again, that ends up being 8. So we have these points on there, which are going to look a lot, the numbers look, we see a lot of the same numbers as we did on our first one over here. So we have 3 1/8. So we start low, 3 1/8. So that was that one. 2 1/4. 1 1/2. 0 1. You guys noticed 0 1 has been part of each graph. That's because anything to the 0 power is 1. When we put in negative 1, we got 2. So we did this, negative 1, we got 2. Negative 2 gave us 4. And negative 3 gave us 8. And so there's that graph. It gets closer and closer to the x-axis, but this time on the positive side. I'm actually going to forego doing part D because we've done 3 of them already. It's going to be exponential decay. Exponential decay means it's going down from left to right. I suppose we could maybe quickly do this one. Let's look at this here in blue. We would have, if we put a 3 in here, we would get 1/27. If we put a 2, we would get 1/9. 1 would give us 1/3. 0, anything to the 0 power is 1. And then here, these give us the reciprocal, so if we put -1, we get 3. -2, 9, and -3, we get 27. So we could graph these points. 3 1/27, it's probably really hard to even put on there. 1/9 is still rough. 1/3, 3, and 9. And so there is a sketch of that graph. So these first 4 that we just graphed, these would be considered parent functions. We'll have other functions related to those, but it's just in this form. It's y equals something to the x power. Actually, let's get rid of... So this is something in this form is the parent function. And what do we notice about these? Well, in all 4 of these graphs, things that we need to notice is the parent functions always go through 0, 1, and the x-axis is always a horizontal asymptote. Strange word. An asymptote is a line that the graph approaches but doesn't reach as it's working out further and further on its domain. Well, there's other asymptotes. There's vertical asymptotes, horizontal asymptotes, slant asymptotes. But for our purposes now, the graph is going to get closer and closer to that x-axis or that horizontal line and not intersect it. All right. Well, now we know what exponential functions look like. Exponential growth look like these two, and they'll change depending on what the base is. Exponential decay are numbers between 0 and 1 in the base, so fractions are in the base, and they go down from left to right. Transforming functions, this is going to be similar to what we did with parabolas and absolute value functions. Remember, A makes it steeper or less steep than the parent function. Steeper if it's greater than 1. Also with A, if A is negative, it's flipped vertically. H, so we're adding something inside the function. We're adding something to x before we actually use that exponent. So the h is going to move it left or right, and if h is positive, it moves left. And if h is negative, it moves right. Right if negative. And that's, we've discussed that before, and I do say that a little bit differently in some textbooks. I'm putting a plus in there. It's really the value that makes this equal to 0. And then the last thing, k. K moves it up if positive and down if negative. Because really what you're doing is you might end up like having this function right here, or even the whole thing. That would give you a bunch of points, but if you add k to every single one of those points, they're all going to move up. Or if you put a negative, it's going to move down. So when graphing exponential functions, the key objects to translate are the original y-intercept. Remember, the parent functions pass through 0, 1. This is incorrect. 0, 1. And the original horizontal asymptote, which is the x-axis. So oftentimes I'll do these in steps. And So let's start with 2 to the x, just 2 to the x. That would be the parent function. In fact, for right now, we're not going to use this times 3 here. We'll save that for another time. So 2 to the x, we actually already graphed 2 to the x. That goes through 0, 1. And then, if you remember, it went through 1, 2, 2, 4. Remember, we can just plug in some values. You can still plug in a few values if that helps. So 3, 2, 1, 0, 1, 2, and 3. 3 is going to give us 8 because we're just plugging it in for the x value. 2 squared is 4. 2 to the first is 2. 1, 1/2, 1/4, and 1/8. I know I did that quickly. You can pause and think through that if you would like. 2, 4, 3, 8. And then we have it getting closer and closer to the x-axis over here. So this is y equals 2 to the x, which, again, we did graph earlier. So we're going to take this thing, and we are going to move it right 4, and we're going to move it up 2. So again, I mentioned it. It says when graphing exponential functions, mentioned it right here, the key objects to translate are the y-intercept and the horizontal asymptote. So we're going to take this is kind of our anchor point or our key point, and we're going to move it right 4 and up 2. So right 4, 1, 2, 3, 4. They're going to move it up 2, 1, 2. In fact, we can take a few of our other points. We can move this one right 4, 1, 2, 3, 4, and up 2. We can take this point and go right 4, 1, 2, 3, 4, and up 2. And let's go with the orange. We can move this one right 4, 1, 2, 3, 4, and up 2. That gives us those points. We had some other ones here. I'll bold this one in black. This was half. We can go right 4, 1, 2, 3, 4. We're at the half, so up 2, 1, 2. And then the other thing to notice is, and we'll go back to a blue color. This was our original horizontal asymptote. It's not. It's going to move right 4 and up 2. Well, moving a horizontal line right 4 doesn't do anything. It looks the same, but it is going to move up 2. So up 2. There is the horizontal asymptote. And now we can graph this thing. I'll do that in, let's just do it in red. So it has the shape of an exponential function. In fact, let's make this a little bit thicker so you can see it. And it has the horizontal asymptote not at the x-axis anymore. It's at y equals 2. And that keeps going and going and going. So that is how you graph exponential functions. The general shape for exponential growth looks like this. Exponential decay looks like this. And then it can be shifted up and down or left or right.